Okay, so we're doing the afternoon session now. It's a pleasure to welcome Professor E. Somanathan from the Indian Statistical Institute at Delhi, who's an expert on environment and broadly theoretical approaches to environmental studies, as well as a theorist of behavior, broadly understanding evolutionary approaches to behavior and other very interesting topics. It's a particular pleasure because when he sent out the paper that, in fact, many of you had read, I'm hoping have read, this was a paper that I read at one of my favorite classes when I was doing coursework. So it was very interesting when I saw this papers. It brought back a lot of memories, which made me feel, one, very happy that these kind of topics are really still current, and two, also a little old, because it was about 10 years ago that I read this. But it was a wonderful paper which really kind of helped me think through some of those issues. And many years later, some people like Elinor Ostrom, who won the Nobel Prize, in 2009, nine, right? Some of the ideas, some of her ideas were spoken about in those in the paper, and it's something that I went back to when she won the Nobel Prize that year. So again, it's a great pleasure to welcome Som, and the way we'll set it up is, for the first hour, Som will speak a little bit about broadly theory and issues of deforestation. Broadly, is it deforestation or broader? Deforestation is the second part, but broadly issues of theory, and then we'll probably break for about half an hour to discuss that part, and then he will have an application with respect to the issue of deforestation. So please join me in welcoming him.
Problem. The basic issue of the commons problem, which I'm sure you're familiar with, is just that you have some natural resource, so it may not even be a natural resource, some resource that over which more than one person has the right to use. And so the result is that when any one person basically extracts resources, they don't take into account the effect of their actions on the others, right? So the effect is there is a tendency, therefore, to over-extract the resource, right? That's the basic intuition. So what I would like to do is, first I'd like to just spend a little time setting up a model which actually is, it's kind of the canonical or the most natural, commonly used model of the commons, and just go through this externality in the commons in some detail, and then I'll go on to talk about basically how governance structures to solve this problem may be analyzed analytically in game theoretic terms. So that'll be so I'll follow on to do that. There are lots of examples, and in the second half of this talk, I will talk about one particular example with regard to forest resources in the Himalayas, right? But there are many such examples of local commons, like fisheries, not ocean fisheries, but inshore fisheries, lakes, ponds, rivers, pastures, which again are often operated as common property, and forests from which various resources like firewood and other things, fodder and so on, are extracted. So these are very common examples of the commons. Analytically also, the common problem is sort of a mirror image of a public good game. So I won't talk about that aspect of it, but it's if if you encounter some, some model of public good contributions, private contributions to public goods, you'll see that there is clearly, it's just basically the mirror image of the same thing. You put a negative sign in front of something, and you're going to get something very similar. Of course, there are variations on these things, so it's not, they're not all the same model, but and I'm presenting one particular model, but it's sort of a useful, it's kind of a useful, simple case. Okay, so so to begin, I'm going to, this wire is going to be a problem. Use xi to denote the effort of person I, and there are going to be n persons. I'm going to use W to denote the opportunity cost of effort. And I'm going to have a harvest or production function for the resource, f of x, where x is just the sum of the individual efforts. Capital X is just the sum of the individual efforts. Okay? So that's the total amount, and I'll use the example of a fishery. So that's the total amount of fish, you can say, extracted from the common pool by the effort put in. So this X can be any kind of input, right? I'm just talking about it as labor input, but it could be any kind of composite input, okay, which has some cost W. Okay. And this production function is going to have very standard appearance. So if you put aggregate effort on this axis, it's going to have this increasing, strictly concave. And so this will be f of x, and this will be wx. Right? So that's the total, that straight line is the total cost of effort, and the f of x is total production. And I'm going to assume that the price of output is 1. So you can think of this thing as being revenue. Okay. I don't need the price, so I don't want to clutter up the thing with symbols. Okay. So if you draw this like that, what that means basically is I'm putting in these assumptions. F0 is 0, F prime is greater than 0, F double prime is less than 0, and F prime of 0 is greater than W. And there is, and F of x is concave enough that it crosses that line. Okay? All right. All right, so, okay, so total profit is just f of x minus wx, right? And it's a very standard problem that's going to be maximized when the marginal product of the input x equals its marginal cost, right? Right? So the maximization happens somewhere here where this distance is maximized when the slopes are parallel. Right? And this I'm going to denote by X capital E, which is for efficient. All right? Okay. So let me just say quickly that so this is the case, this is what maximizes the aggregate profit. So if n was equal to 1, right, there would be one owner of this resource, and this is what they would do. This is what that person would do. Now, let's go to the other extreme and consider the case where the resource is open access, right? So it's a fishery where anybody can come and fish. It's the sea, okay? In that case, what is the level of aggregate effort that we would expect? So there's free entry. What would you expect with this setup? Anybody? So anybody can come and fish. Anybody can come and put in some X. Okay, so let me just say quickly what they get, right? I haven't spelled out the payoff to an individual when there's more than one individual. So let's say that, so this total profit I can denote by capital pi, and the profit to person I, let me denote by pi sub I, okay? And we'll suppose that that's equal to basically that person gets a share of the revenue, all right, in proportion to the amount of effort they put in. So xi over x is the share of the total effort that person I is putting in, right? And they get that amount of the revenue, right? And their cost is just wxi. Okay? So that's the formulation, right? This is a very standard natural formulation. I think it was introduced in a paper by paper or book by Dasgupta and Heel in the 70s, but it may be older than that for all I know. So basically if xi is, say, the number of, so another example is this lobster fishing, which I'll talk about a little bit more. So with lobster fishing, what you do is you have what are called lobster pots, which are basically traps. So you go out in a boat, right, and you lower this trap to the seabed because the lobsters live on the seabed in shallow water. And you put the trap in, and then it's tied to a float, right, which marks the place where the trap is, and you leave it there and go off, right, and then you come back after a day or two and you pull it up to see whether there's a lobster in the trap, okay. So in that case, xi could just be the number of traps that person I puts in. Capital X would be the total number of traps in the water, okay. F of x would be the total number of lobsters, right. So if I have half the traps, I get half the revenue. That's the, if I have a third of the traps, I get a third of the revenue. That's the formulation, okay. And of course, I pay the cost of my own traps, but not of anybody else's. Now, what would happen if anybody could come in and just put traps in the water? And how many traps, what's the total number of traps that you would expect? So would it be this, for example? It's where the intersection would be. And why is that? Exactly. So at that point, you go on until the point where profits are zero, right? And that's what happens under free entry. Why would anybody, supposing there were positive profits to be made, you were here, right? If you're here, then this is the total profit, correct? So if you put one more trap in the water, you're going to get some additional profit, right? So why would you pass it up? You would do it. So it's not possible to have an equilibrium with open access, which wouldn't take you to the point where all the profits are wiped out. Just the standard free entry condition, right? And I'm labeling it with XO for open access. Okay, so this one is for open access. And this one is, E is for efficient. Okay. So now I want to go on to analyze what will happen in the intermediate case where you have a fixed number of people who can harvest the resource. So this is a common property or common pool situation where where n is fixed now. It's not unlimited. How does that change things? Okay, so let's see. So in order to do that, first I'm going to rewrite this in terms of the average product. Okay. So, sorry, that's my wife's. So if you take f of x by x, that's the average product of labor, right? That's the average product of the input x, f of x over x. So this can be written as xi times the average product. This is A of x minus w, right? By the way, can everybody see this when I'm writing down here? Yeah? Heads are not in the way? Okay. All right. Okay, so where Ax is, where should I write that? Yeah. So Ax is f of x by x. Okay? Say average product. Okay, if we rewrite this way, right? Now let's look at the first order condition for one of the agents, right? A profit maximizing agent. So we get so if you differentiate with respect to xi, and I'm writing this as a I'm writing like this to indicate it's a partial derivative. So I'm keeping the other people's x's constant. I'm taking them as given when I'm choosing my own xi. All right. So if you differentiate here, you get, well, differentiate with respect to xi and multiply by this, you get ax minus w plus keep xi as it is and differentiate this with respect to xi, right? So xi times, of course this is a constant, so this is just the derivative of this with respect to capital X and then times derivative of capital X with respect to small xi, which is just 1. All right, so it's just a prime x, right? And so the first order condition here is to set this derivative equal to 0, right? Okay. And now let me just rewrite the first order condition here in terms of this average product, so you can compare the two, okay? So for this one, if you divide this and multiply it by capital X, right, you get capital X times f of x over x minus wx, right? So this is just equal to capital X times ax minus w, right, this one. So now this first order condition, this one can be rewritten in terms of this, and you get something very similar to this one, right? The only difference is you get the same ax minus w plus it's capital X times a prime of x equal to 0, right? So let's compare these two. This is what one of the persons would do taking the other people's actions as given when they're trying to maximize their own profit. This is what somebody who's trying to maximize the aggregate profit of all of them, the sum of their profits, would do. Okay? And we know already that this one is what, since this maximizes aggregate profits, let us consider what this looks like, del pi I by del xi looks like at the level of x equal to xe, which satisfies this condition. All right? So supposing you're at that situation, you're over here. All right? Now is the first derivative of profit of a single agent positive or 0 or negative? Okay? That's the question. Right? We know that this is 0, correct? At xe. So what about this? Well, what's different about this is xi is smaller than capital X. Correct? And what about a prime of x? Well, that's the average product, right? But the average product is negative. this is the derivative A prime of the negative, it's the derivative of the average product is negative because the average product is decreasing. And what is the average product? It's just the slope. It's just the slope of any line drawn from the origin to a point, right? So it's the slope of a line like that. That is the average product at XE, this is the slope of that line, correct? And you can see that as you keep going out, the slope of that line will decrease, right? So the average product is falling because the marginal product is falling, right? So that means that this has a negative sign, correct? If this has a negative sign and xi is smaller than x, right, then that means that this expression at the level at which makes this equal to 0, at this level xe has to be positive, right, because you're subtracting a smaller amount here than you're subtracting here. Okay? So what we see is that at xe, so there is an incentive to go further than the efficient level, all right? And so you're going to end up at a situation when all of these are satisfied. So let's just rewrite this. So this equation, I'm really filling up this place. This equation can be rewritten as xi equals ax minus w divided by the negative of a prime of x. All right? Can you see that? It's a bit light. Yeah, I better use the other one. Huh? Okay. Fine? Okay, so what do you see from here? Well, what you see is that this holds for every single person, right? When because of the symmetry of the problem, what it means that everybody's effort level is going to be equal to this. So it's the same. All right? So that's going to be the Nash equilibrium, and in that Nash equilibrium, as we saw from there, this effort level xi will lead to a capital X, which is greater than the efficient level. So there's going to be over extraction. All right? Relative to what is efficient. All of these people could be better off if they all restrain their extraction, but there's no individual incentive to restrain the extraction. And so we conclude that, therefore, xe is strictly less than xn is strictly less than xo, where xn is this Nash equilibrium, is the aggregate effort level that corresponds to the Nash equilibrium where everybody's trying to maximize their own profit. Is that okay? So this inequality is what I just pointed out. What about the second inequality? How do we know that this is actually strictly less than the open access level? It follows from this first order condition here. Okay? This thing has to equal 0, right? But we know, we know that this is negative. But if this is negative, then this has to be positive. Right? So if this is positive, then you can't be at this situation, because in this situation, the average product is equal to the wage. Right? You must be here where the average product is above the wage. Okay? So therefore, xn must be less than x0. Okay, so Nash equilibrium leads to overexploitation relative to what is efficient, but not as much overexploitation as you would get under open access. Under open access, there are no profits left, right? The rent from the resource, to use the technical term, the rent from the resource is completely dissipated under open access, where it's only partially dissipated under common property, unregulated common property. You can think about this kind of more intuitively without all the maths. I mean, to just think about that lobster example I gave you. So think about what's happening there. So what's happening there is that people are putting these traps in the water, right? And so the decision for an individual person, right, is to choose that xi, which is the number of traps they're going to put in the water, right? And now think about what I do when I put in one extra trap, right? If I put in one extra trap in the water, right, and I already have a bunch of traps in the water, that trap is going to catch me perhaps some additional lobsters. All right, some more will go into that pot on top of what I'm getting from my other traps. But on the other hand, what's also happening is that some of the lobsters I would have caught in those other traps are now diverted to this one, right? So that is the effect. When I increase xi, right, by 1 unit, I'm going to get, this is the cost of the additional lobster pot. And this is the average amount of lobster revenue I expect to get from that pot in addition, right? From that one extra pot. But it's going to drive down the average revenue I get from all the other pots I have in the water, right? Because it's going to divert lobsters from those into this one, right? And that's this negative term, okay? So there's a positive term and there's a negative term. I'm getting more on the margin, but I'm getting less on all the inframarginal units. All right. Now, why is this not efficient? It's not efficient because I only care about all my existing lobster pots. I don't care about all the other people's existing lobster pots, but I'm diverting from all of them, not only from mine, right? And that's the difference between this and this. Okay, so that's why you have this externality. So the incentive is to put too many pots in the water. Then it's efficient. Okay. All right. So that's really the simple static model of the commons. Right now, of course, there's also a dynamic externality here, which I'm not taking into account, which is that when you overfish from this common pool, or you overgraze a pasture, or you overcut from a forest, you're going to have less left next period. So there's going to be a stock depletion effect. And I'm not going to have the time to talk about that today, all right? But it's in the paper, so if you want to read more about that, it's discussed in the paper. Okay. All right. Okay, so the roundabout, I would say, in the 1970s, so when, for example, Dasgupta and Heel published their book in 1979 on the economics of exhaustible resources. This model was in that book. And the thinking then was, well, the common property is inefficient. It leads to this inefficient outcome. And so if you want to solve the problem, you either have to privatize the commons, cut it up and divide it up among people, or you've got to have regulation, right? And of course, people just assume that regulation has to be by the state. Okay. There were a few people who pointed out that, in fact, if you bothered to actually go and look at commons around the world, you found that many of them, if not most of them, were neither perhaps privatized nor were they regulated by the state. But nor was it the case that they were totally unregulated. There was some kind of local regulation, local kind of cooperation, local governance arrangement to govern the extraction of these resources. Right. And that was a great contribution of Eleanor Ostrom. What she did was she put together and wrote a book which sort of synthesized the findings from a huge number of studies that had been done by lots of people, mostly outside economics, mostly anthropologists, sociologists, various scholars of various kinds and various disciplines, some economists, some political scientists, and so on. And what she did was essentially amass this enormous body of evidence which showed that around the world at different periods, you had local commons governance arrangements. And that these governance arrangements in many instances appeared at least to result in a situation where you didn't get a serious over-extraction problem. Okay? And so that led to a rethinking of essentially how, what the economics of common property really is. And that the simple policy conclusion that you got out of the simple static model of the commons, which I just showed you here, which says that, look, since you're going to have overexploitation that's inefficient, you should either privatize or regulate. That doesn't necessarily hold, that self-governance is possible. Okay. So then the next question becomes, well, how is this self-governance arranged, and under what conditions does it work well? Under what conditions will it not work well? So we want to try and understand how this, under what conditions does self-governance work well? Because the other thing that's clear from Ostrom's book is that it doesn't always work well. But there are many instances where you do get this commons, the tragedy of the commons in full force. Okay, so there are basically three kinds of models which three types of models or theories you could use to explain governance in the commons. One is what you might call the mini-state model. So in this situation, you have a village or something. There is a local autocrat, the zamindar or whatever, the panidar or somebody. And he basically says, okay, everybody will do this, and they do it. All right. So it's all regulated. Okay, so that's the mini-state model. Of course, it doesn't have to be an autocrat. It could be some kind of democratic state, but whatever, something. A second model which economists, of course, came out with was a repeated games model, right? And here the idea is that you play this simple static game over and over and over again, and if you're familiar with the notion of subgame perfect equilibrium in repeated games, it's basically what you can show is that there's always going to be a subgame perfect equilibrium here, provided people are patient enough, that is, they value future profits highly enough. Then there'll always be a subgame perfect equilibrium here where you get the efficient outcome in every period, right? And the basic intuition behind that is that, look, in every period today we will do the efficient thing, because if anybody deviates from that and extracts more than their share of the efficient amount, then in the next period everybody will over extract. All right, and so then you would be worse off deviating from the equilibrium in which you all do the right thing, because that would lead you basically lead you to play this Nash equilibrium, this inefficient Nash equilibrium. I didn't draw it here. The inefficient Nash equilibrium, which is somewhere in between these two, over and over and over again, right? And so you would lose by doing that. If you valued future profits enough, then it's not worth getting a little extra today, because you're going to lose a great deal in the future. Right? That's the intuition behind the repeated game approach. A third I realize this thing is probably in the way. You can't see what I'm writing here either, right? The people sitting on this side. Okay? All right. So I should have done that sooner. So the third approach is, there's some kind of social norms and social sanctions which govern people's behavior in the commons. And so what I want to talk about for the rest of the next 25 minutes is a formal game theoretic model of this third approach. Okay. Why am I not particularly enthused about this approach? Is okay. It's fairly straightforward, right? The trouble is it's quite uncommon. So you don't often have, really state-level arrangements. In many of these situations, what you observe is not something that you would think of as a government governing these things. Okay, it's something much more informal. okay, or it's something much more local, which has to be locally self-organizing. And so you have to explain how that self-organization happens, all right? So this approach I'm not terribly enthusiastic about for the simple reason that this approach has, these equilibria have very peculiar properties, some of them. So for example, there are lots and lots of equilibria. Just one of them happens to be the efficient one. But there are lots of intermediate ones which are not efficient. Playing the Nash equilibrium forever is also an equilibrium. And this doesn't require any sanctions, right? This doesn't require any norm, any kind of social punishments, any disapproval of somebody else's actions. So the way you would react in this repeated game to approach, the way you would react to somebody extracting too much would be not to sort of punish them or to speak to them or to try and deter them in some way. It would be simply to extract more yourself straight away, all right? And so to use that as a model of how cooperation is actually sustained doesn't seem to be empirically viable, right? If you actually observe commons, you don't observe that. What you do observe is you do observe sanctions, right? And sometimes they're very subtle sanctions. So one of the things that came out of Eleanor Ostrom studies is very often these self-governing arrangements, you have some kind of informal arrangement or sometimes fairly formal also with rules written down and so on. But one of the things that's quite characteristic of these arrangements is if you look at the size of the punishment that somebody gets for taking too much water from the irrigation canal or for, cutting firewood, cutting down a tree when they weren't supposed to or whatever, you'll find that very often the punishments are very small, okay? And you would think that, look, this punishment can't possibly be enough of a deterrent for a product that's that valuable, okay? And so something else is going on, right? The punishment, many of these punishments are symbolic, right? They're sort of telling that person, look, the community is watching you, okay, and we disapprove. So it's more the social aspect of the punishment that matters. So that's what I want to model formally. And why do we want to model it? We want to model it because we want to have some kind of understanding for under what circumstances social norms and sanctions can result in the efficient outcome. Okay, when is that viable? So we want some understanding of when it's viable and when it's not. Okay, so now I want to move to modeling this. Okay, so same structure of the game, but I'm going to reduce the effort levels to just 2 effort levels. So rather than allowing people to choose a whole continuum of effort levels from 0 to infinity, I'm just going to have them choose 2 possible ones, which I'm going to the low one and the high one, XL for low effort and XH for high effort. Okay. And instead, I'm going to, by reducing the complexity here, I'm going to add a layer of complexity by having a second stage. Okay? So in stage 1 of the game, players choose X equal to XL or XH. All right. And in stage 2, players observe what everybody did in the previous stage, right, what effort levels they chose, and they decide punish those who chose XH or not. Okay. Why would I want to punish those who chose high effort level? Because here you can think about the low effort level as something that if everybody did it would lead to something efficient. High effort level, if everybody did it, would lead to some over extraction. All right. So that's why you want to, you might punish those who chose the high effort level because that's the socially undesirable one. That's what's imposing the negative externality on everybody else. All right. Okay. So if punished, the cost to you the damage you suffer from punishment is delta, okay? And the cost of punishing one person is gamma, okay? And both of these are greater than 0. These are numbers greater than 0. That's what we assume. Okay, so you suffer some damage from punishment, these social punishments, social sanctions, you can think of them. But it's not costless to sanction somebody, right? If you convey your displeasure or your disapproval to somebody of their behavior, they might resent it, right? And that can carry some costs for you. So you can't expect that the punishment cost is 0. If it was 0, then solving this problem is very easy. Basically, everybody has to do the right thing. If they don't do the right thing, they get costlessly punished. End of story, right? So, but it's not so easy. Okay. All right, so now I'm going to suppose that there are 3 possible strategies in the population, all right? There are 3 possible strategies that players could adopt. The first one is going to be D, and this is going to be for defector from the prisoner's dilemma terminology of defect, okay? And the D strategy says choose XH, don't punish. So the payoff, which I'm going to call pi D, right, is going to be your first period payoff, which is XH times AX minus W, which is as before, except that here he's choosing the high effort level, XH, right, minus, but the trouble with choosing the high effort level is now because there's this punishment stage in the game, you could get punished, right? How much punishment? Well, you get punished delta by each person who punishes you, causes a damage delta. How many people punish you? Well, it's going to be the share of enforcers times the number of people, N. Okay, so N is the number of people, and S sub E denotes the share of people playing the E strategy. So there are going to be 3 strategies here, D, C, and E. Maybe I should have written C first. But anyway, I'll come to what SE is. It's first let me write down C, and this strategy is choose XL in the first period and never punish in the second period, second stage, all right? And the payoff to this strategy is you choose the low effort level, you get the average product, low effort level times the average product of effort minus the average cost, right? So it's the average, this is the average profit per unit of effort times the effort you put in, right? And that's it. You don't punish anybody and nobody punishes you, okay? And the third strategy is E for enforce. Okay, C is for C for cooperate, as in the prisoner's dilemma, cooperate. Okay, and here you choose, okay, sorry, I didn't tell you what the E strategy is. So the E strategy is choose XL, so you socially responsible, you choose the low effort level and punish those who defect. Okay, and what is pi E? It's equal to XL AX minus W. This is the first stage payoff. You're choosing the low effort level. Minus, you're going to bear the cost of punishing the people who defected. All right, how many people defected? It's the share of defectors, D, SD times the number of people. So that's total number of defectors times the cost of punishing a defector, gamma. No, you don't punish anybody, so you don't bear the cost of punishing anyone. However, what happens to you is you could be punished, right? Delta is the cost of being punished by one person. SE times N is the number of enforcers in the population, therefore the number of people who will punish you. Okay? So SC, SD, SE this is the vector of shares of strategies. They're shares of the shares of the total number of people playing a particular strategy. And I'm going to ignore the fact that if you have a finite number of people, then these shares can only take particular values. I'm just going to treat it as a continuous variable, okay? Just as an approximation.
So it doesn't include the probability of getting punished. I mean, that is too low. It just assumes that.
Here. Yeah, so here it assumes that you get punished with certainty, but then delta could just be the probability of being punished times the damage from punishment. So you can collapse that into one here, just for simplicity. But yes, in general, of course, there will only be.
The results will be very different.
No, they won't. It doesn't matter, right? Because it doesn't matter whether this delta is some probability times some number. What is going to matter is the size of this number. Okay. All right. So very quickly. So what is the point of doing this? Well, the point of doing this is we want to understand what the long run behavior of this system is, right? Of this social system. So we want to know in the long run, what can we expect the shares to converge to? All right. So this is a share of people playing the C strategy. This is the share of people playing the D strategy. This is the share of people playing the E strategy, which is just all the rest who are not playing C or D. All right. We want to know what this will converge to, right? Because that gives us a prediction for what we should expect. All right. And how do we model how this behavior changes over time? We're going to do it using the notion of evolution, right? And the idea is going to be basically that supposing a particular strategy, say pi E, is giving a higher payoff than say than the strategy D. So suppose pi E is greater than pi D, right? At some point in time, then we're going to assume that because one strategy has a higher payoff, more people start adopting the strategy with the higher payoff. All right? So the strategy with the higher payoff, its share will grow in the population. Strategies with lower payoffs, their shares will decline in the population through some process of imitation and learning that's not modeled. That's not, but that we expect will be the case. People tend to learn and switch their behavior to actions that give them higher payoffs. Right? They have some intelligence. But unlike the standard game theory model in which this entire learning process is collapsed into an instant, in this model, the learning process actually happens in real time. Okay, in real time in the model, in model time. Whereas in game theory, everybody kind of instantly computes what is the best thing to do and does it. Okay? Here we suppose that people are not that smart, but they're not stupid either. They do learn. But they don't know everything and they can't see everything, so they don't learn instantly. What's the best thing to do? So that's the assumption here in this framework. And so how is it set up? It's set up it's set up by basically assuming that these shares, this vector of shares follows a differential equation, okay? And it's going to be basically this. So what does that mean? The dot here means the time derivative. Okay, so it's dSi by dt, where t is time. So this is the rate at which the share of strategy I changes. Okay, and we say that that's going to be proportional. So if you take, if Si is positive, then you can divide through by Si, in which case what this becomes Si dot by Si is the proportional growth rate of Si, right? And that is just equal to the amount by which the payoff to that strategy exceeds the weighted average payoff in the population. This pi bar denotes the weighted average payoff in the population. All right. So if pi I is bigger than pi bar, if this strategy is doing better than the average in the population, then this will be positive, which means the growth rate will be positive. So the share of the strategy will grow. All right, and vice versa, of course. Okay, and so then you can ask yourself, well, now these things are changing over time, and as time progresses in the long run, what will these shares converge to? That's the question. That's going to be the prediction of the model. Okay? So for that, we have to ask ourselves, what are the long run outcomes of this dynamical system under the assumption, basically under this assumption that this is true. And notice that this is just a special case of capturing the idea that if the payoff to strategy I exceeds the payoff to strategy to J, then the growth rate of strategy I exceeds the growth rate of strategy J. That's satisfied by this special case. This is called replicator dynamics. But actually that part is not important. The results actually go through a more general case. Okay, so what are the results? Let me just draw a picture since we are running out of time. Except that it's XH instead of XL. Oh, and minus, sorry. There's the minus, I better write it down. So let me write it down here. Pi d is XH AX minus W minus SEN delta. Okay? So let's draw this. I'm going to put the cooperator share on this axis. I'm going to put the defector share on this axis. Okay, so since these are shares, they run from 0 to 1. Right? Okay. So everything happens within this triangle. Right? The shares have to add up to 1. They are non-negative. All right? If both the cooperator share and the defector share is 0, right, then the N share is 0. SC plus SD adds up to 1, and so on. Okay? All right. So, all right. So we need two notions of stability now of a state. What do I mean by a state? I mean a point in this triangle. That's going to be a state of the system because that describes what everybody's doing, right? So, there are two notions I'm interested in. Well, three. Well, preliminary notion is what is a steady state? Steady state means that Si dot equals 0 for all I. Okay? That means that if you're at that state, then there won't be any change. You won't move away from that state. Okay? But that's not stable, right? We're interested in a stronger notion. We want not just something is a steady state, but it should be stable. What do we mean by that? Well, I mean that a state is going to be stable if you start at a state close by, right? Then you won't move away. You'll stay in that neighborhood. Okay? That's stability. All right? And then there's a stronger notion of stability called asymptotic stability. And asymptotic stability says, if you start at a state close by to this one, right, then you will converge to this state in the long run. You'll move towards this state in the long run. That's an asymptotically stable state. Okay? And it's a notion of local stability, which means that if you start nearby at some state which is close to this state, then you will converge to it. All right. So, what can we say? Is this a stable state? Okay, before we go there, let me just first say that nothing in the interior can be a steady state. All right, why can nothing in the interior be a steady state here? So for a state to be stable, it has to be a steady state, right? So stable states are always steady, okay? And asymptotically stable states are also steady states. So it's a sort of hierarchical concept. Why can this never be even a steady state, let alone stable? Well, because if you're in here, right, then all the shares are positive. It's only on the edges that at least one share is 0. If you're in the interior, all the shares are positive. Now, if all the shares are positive, compare pi c with pi e. Look at these two. They're exactly the same except for this term, right? The cooperators and the enforcers. The enforcers are bearing punishment costs. The cooperators never do that. They just passively cooperate, right? They don't try to make other people cooperate as well, right? So they don't bear that cost. So enforcers always have a lower payoff because of this punishment, provided SD is positive, right? But if you're in the interior, then SD is positive. That means this is less than this, correct? But if this is less than this, then you can't have pi I equal to pi bar, right? You can't have pi, because pi c is greater than pi e. So it can't be the case that this is 0 for all three, right? And therefore, if you're in the interior, there is always selection pressure, evolutionary pressure against the enforcers in favor of the cooperators. Okay? So you can't have a steady state in the interior. Therefore, the only candidates for steady states are actually on the edges. All right? Okay. Supposing you're on this edge, could there be a steady state on this edge? So what is this edge? This edge means that there are no enforcers, right? Cooperator share plus defector share adds up to 1, right? So there are only cooperators and defectors. In that case, look at those payoffs. What can you say? SE is 0, right? So this term vanishes. So you have to compare these two. Which one is bigger? This one is bigger because XH is bigger than XL, and this is the same, right? So the defectors are getting more because they're getting more first stage profits and they're not being punished in the second stage, correct? So if this payoff is bigger than this payoff, then the defector share must be growing and the cooperator share must be falling. So you can't have a steady state here, right? If you're on this edge, then the arrows point this way. You must be moving in that direction. Right? Okay. Now let's look at this. Could this be a steady state, a stable state? So what if everybody's a defector? Well, if everybody's a defector, then SD is 1. SC and SE are 0. Okay? And therefore, just by definition here, if SC is 0, SD is 0, then those shares are 0. Those growth rates are 0. Right? So if two of them are not changing, then the third can't change either because the three add up to 1. Right? So this is a steady state. In fact, any point, any of the three corners is a steady state. Right? But that's not interesting enough. We don't just want to know whether it's a steady state. We want to know whether you're going to go there if you start from somewhere else. Right? So we want to know whether the arrows here point like this or do they point like this? Which way does the change occur if you're close to this point? Clearly on this edge the change goes this way, right? But what about here? Which payoff is going to be higher? Which payoff, and therefore which strategy's share is going to grow? So now you're close to SD equal to 1. You're not exactly at it. What does that mean? It means that this SE share is close to 0. Right? But if it's close to 0, then this term is small, right? If you're sufficiently close to that point, then this term is very small. And therefore, the fact that xh is bigger than xl will overwhelm this term, which is very small. Correct? And so it's going to be once more the case that pi d will be bigger than pi c, right? But pi e we know is always smaller than pi c. Correct? Therefore, pi d is the one with the highest payoff. Therefore, share must grow. Right? So if you're close to this, then the arrows must point this way. So this is an asymptotically stable state. That's the bad news. The bad news because it tells you that in this situation, everybody doing the wrong thing, everybody playing the Nash equilibrium is asymptotically stable under these learning dynamics. Okay? Under these evolutionary dynamics. Locally. So if you start off from a situation where most people are over-extracting, you will end up in a situation in which everybody is over-extracting. Right? Because that's what the incentives lead you towards. Okay. The question is whether there's anything else here, any other stable states. Okay. So the first thing I want to note is that everything on this edge is a steady state. Steady state meaning that if you are on the edge itself, then you won't move. The shares will not change. Why is that? So remember, what is this edge? This edge, in this edge, SD is 0. What does that tell you about the payoffs? SD is 0. Exactly. Pi E and pi C are the same. Payoff and is also equal to the enforcer payoff. So this is 0 for cooperators and enforcers. So this will be 0 also. Okay? So these are all steady states. If you're on the edge, you won't move away. Now we have to ask about stability. If you're near the edge, will you not move away? All right? And the answer is really, well, there's going to be some interval here, okay? And in this interval, it's going to be, okay, so let me there's a condition that is needed. So this stability, the stability here of this state is unconditional, right? In this problem, no matter what the parameters are, under these assumptions, this is asymptotically stable. It's going to turn out that there is an interval here of stable states. But this interval only exists under a particular condition on the parameters. Okay? And that's what's going to be interesting. That's what's interesting because it allows us to say, well, these are the conditions under which everybody choosing the low extraction level is a possible long-run outcome of this social system. Okay? So what is this? Basically, I'm going to call this A bar, and this A bar is going to equal 1 minus xh minus xl times I should write this a little carefully. So okay. Okay, so what does this mean? So notice that delta is in the denominator here. Okay. So delta is the damages suffered by defectors if they get punished. If this is big enough, then if this delta is large enough, this term is small, right? Okay. If delta is large enough, this term is small, right? And that makes it more likely that this A bar, that this thing is smaller than 1, all right? The larger is delta, the smaller is this term, and the further out this A bar is, okay? All right, and whenever you're less than this, you're going to have these states being stable. And what's the intuition behind that? The intuition is simply this, that you need a certain number of enforcers, right? Remember, when you're at this point, the enforcer share is 1, okay? So imagine that you're at this point, okay? Then means the enforcer share is 1, all right? In that case, defectors, okay, are going to do worse than enforcers if it's true that xh minus xl times this minus delta n, right? You multiply through by delta n here, right? If it's true that delta n minus this numerator is greater than 1, then what it's telling you is that the payoff advantage that you get from extracting more in the second stage gets outweighed by the punishment in the second stage. Sorry, the payoff advantage you get from extracting more in the first stage gets outweighed by the damages you suffer in the second stage. All right? That would be true if delta n were bigger than this, right? But that is the condition for this A bar to be positive. All right? So if A bar is positive, then therefore this condition will hold, right? Which means that these damages are big enough to outweigh these punishments. All right? And in that case, if you have an enforcer share which is sufficiently close to 1, therefore in this interval, then the defectors essentially are going to suffer punishments which are high enough to ensure that the arrows over here basically point in here, into this. Okay? And if you're outside this, then you will end up going there. So there is some basin of attraction here, under which if you start close enough, you'll end up here, with everybody choosing the low extraction level. If you start anywhere else, you end up there with everybody choosing the high extraction level. Okay? And what's the economics of this? It's all in this. Everything is in here, right? Everything is in this thing, that it has to be the case that SE and delta is greater than xh minus xl times A and xl minus w. Instead of the capital X, I have an XL here just because I'm looking at the situation where everybody is choosing the low extraction level. Okay? But otherwise, the same thing. Now, under what situations is this likely to be the case? Historically, we observe a situation over the last 200 or 300 years where many local commons, which were well governed, broke down. The governance broke down, and you got over extraction. All right? What do we think is going on there? Well, what this model suggests is, why did this happen? Well, this happens because these local villages are getting connected to markets. Okay? They're getting connected to the outside world. What does that do? Well, this A remembers the average product of labor. So they get access to new technologies which are more efficient, greater harvesting technologies. That raises this term. But if it raises this term, it makes it less likely that this inequality will hold. Okay? Moreover, transport costs fall, so you can extract a natural resource in one place and sell it in an external market for which you can get a higher price. Again, this average revenue product of labor goes up. Okay? Again, that makes this inequality less likely to hold. All right? In this world in which you have access to external markets, new technology, higher prices for the product possible, migration opportunities out of your village closed society. What do these migration opportunities bring you? They bring you escape from these social sanctions, right? If it's the case that there's nowhere to go, you're born in this village, you're going to live in this village until you die, you better get on with everybody else, right? You better not get other people angry with you, right? But in a situation where there's some external opportunity, those social sanctions are less important now. Okay, so they have less bite, right? This goes down, right? So what this model helps us to do is helps us to understand the conditions under which it's likely that this stability can break down, right? And notice that another thing about what this model tells you is that this is a process that happens gradually, right? You get gradual access to these markets. Prices go up, technologies improve, these social norms start to erode, right? And as long as you're within, this thing starts to shrink. But as long as you're still within it, right, overall behavior doesn't change. Overall behavior doesn't change. You're still at that state which is still stable, right? But once you drift past this, right, you start off, supposing you're at this state here, and these parameters change so that this thing moves here. After that, this is no longer stable. So any kind of noise, any kind of random perturbation to the system will push you away. All right. So the process is one in which you will not, before the change occurs, change is occurring, right? The parameter values are changing over time, but the behavior doesn't change at all until you cross the threshold. After you cross the threshold, then you're vulnerable to the smallest shock. The smallest shock will mean people will start to defect. They'll discover that, by the way, they're not getting punished. More people will copy them, right? And then eventually you'll get to just a complete cascade as everybody finally gives up and says, well, we can't do anything about it. We might as well also just get what we can while the going is good, right? You end up in that situation. And notice that you can have situations where all these changes occur, and then as a result of this change in the economy, wages start to rise, right? Because the economy starts to grow, it's a market economy, capital is accumulated, and wages start getting pulled up. If wages start getting pulled up, then the effect goes in the opposite direction, right? If the opportunity cost of labor goes up, then this term falls. Okay? So the advantage to being a defector falls. Problem is that tends to happen slowly, right? The wages tend to catch up after a long time. Meantime, the social norms have gone. You're already over here, right? After that, the wages may go back up and this inequality may once again hold, but it's too late. Now you're locked into this bad equilibrium, which is stable. Okay. There's a lot more which is in the paper, but I'll stop here. Let's have a break.
So, 15, 20 minutes on this, then we'll go on to, we'll go to deforestation, depending on
how much time there is. Yeah.
Are there particular questions on this, the approach, any thoughts about what it says for governing commons generally and so on? Any thoughts, questions?
Presentation to differentiate it between three kinds of ways of dealing with this issue. So you said there would be state or there would be. So you could think in terms of repeated games and then this one. If you sort of compare the repeated games of this model, I don't see there is a very big difference between the because in a repeated games you ultimately come across a number of regimes and some of them may correspond with this and they are going to survive, whereas the others in which defectors or whosoever dominates will be completely decimated. So you will have the sub-Saharan outcome as well as the protected Middle Eastern, agricultural enclaves as well. So I don't see that there's either or, that either you do repeated games or you do sanctions and punishment. The second point that I have is that social norms, and this is also linked to the first one, is that some of the social norms emerge in repeated games. So you interact with each other again and again, and the equilibrium of the repeated game becomes the social norm. Now that's one. Now once these norms are formed, even if the socio-economic conditions change, the norms may change much more slowly than the wages. to give you an example, I mean, after the advent of modern hygiene, etc., halal and kosher have no relevance at all. They still persist, and there are so many social norms which used to bind together communities, and they are still persisting even though they have the socio-economic basis that initially brought them into existence is no longer there. So when you say that the wages catch up slowly, so the norms also change slowly. Even though the market is intruded, people still go on behaving as if the old regime still holds.
So I think the point is that there is what this model does is it helps to explain persistence. So if you you can ask the question, why is it that this a particular norm is so persistent? Well, it's persistent because there is some kind of evolutionary pressure which holds it in place once it's there, right? That's the idea here. So, but the point is that certain norms are not stable, right? They may persist for a very long time, but then they're not stable once a particular configuration of parameters has changed. That's the basic idea. But if you try to interpret an equilibrium of a repeated game as a norm, I mean, game theorists do that all the time, right? I don't find this particularly convincing because if you think about the behavior that the repeated game requires, right? These kinds of repeated game equilibria are held in place by the threat that you will do the absolute opposite of the norm if somebody deviates, right? So in this model, for example, it's basically saying that, look, everybody should extract the low level, but if somebody deviates, then we'll punish them by, in the next period, ourselves violating the norm and extracting the high level, right? That's very counterintuitive. If you think about the way actual social systems work, you don't punish somebody who violates a norm by all of you violating the norm so that you're all worse off, right? So that that person then, at that point, it wouldn't have been worthwhile for them to do it, and then they're supposed to foresee that and therefore not violate it to begin with. Yeah? You see the structure of the equilibrium is essentially something that it's hard to believe occurs in situations like this. Whereas what this model does is it's much more believable in the sense that it's not saying that the punishment is not a withdrawal of cooperation. The punishment is something else. It's not related to the actual game, right? It's not saying that if this guy cut too much firewood today, we'll all go and cut down the forest tomorrow, right? It's saying, well, if he cut some firewood today, we're going to be nasty to him when we sit in the tea shop in the evening, all right? That's the nature of these social sanctions here. That's what that delta is, right? And the fact is that why does being nasty to me when I go and sit in the tea shop in the evening matter to me, right? It matters to me because it matters to me in some contexts. So it matters to me in a context in which I actually have a dense social interaction with these people. In which case, if they start to behave nastily to me, I become a social isolate, right? And that's really a strong consequence. Whereas if I'm in a city, right, this kind of thing is not going to work, basically because if those guys, don't want to interact with me, I have plenty of other people to interact with. So that's the sense in which this model is trying to pick up all of those things. It's trying to pick up why it is that social sanctions matter and the circumstances under which they matter.
This can easily be incorporated in a repeated games framework. The punishment in the repeated game need not necessarily be that we all over harvest. It need not be that. There's nothing in the repeated game framework which compels you to make the punishments strategy to be the exact opposite of the cooperation strategy. So,
but then you have to, but then you have to have a more complicated repeated game to begin with. So you have to take this original game, right, which was just the extraction game. You have to add a punishment stage to it, right? And then you take this complex game and instead of doing evolutionary dynamics on it, you repeat it, right? You could do that. Yeah, I agree that you could do that. But the question is then, why do you need, if you're actually going to follow an analytical strategy, I can ask you the question, why did you write down this more complicated model? You don't need that more complicated model in order to generate an equilibrium in which everybody chooses the low extraction level. You could have generated that same equilibrium with the less complicated model. Right.
Other questions? I have a question. These are two questions. The first one, I mean, they're both not directly related with the model itself, but perhaps broader implications. So let me try the first one. It seems that for the way that you posed the last discussion about, for want of a better kind of phrase, the things fall apart in small communities story. I think it's definitely, it resonates. But at the same time, you have norms that sustain in modern societies, for very marketized modern societies, which have to do with certain sorts of governance of commons. I mean, I'm talking about, for example, not littering and things like that. I'm wondering how you see those things within the context of the model, and how important do you think those things are for even in modern society, modern society is probably wrong, but large-scale industrial societies, as essential for governing society. The reason I ask is, you take what's happening here. You can certainly see, for example, in our cities or in Bangalore, a sense that the commons don't matter, which used to perhaps not be the case before, but now, but I can see that in other societies, the norms to maintain the commons, to not litter, to create that the public sphere, the public space, are still very strong. So I was trying to get a sense of how you see that, either within the context of the model or just generally. Did the question make sense?
Yeah. So I mean, I can see it within the context of this model, but slightly, but the same basic framework, but slightly different application. So why is it that drivers in India have such terrible manners on the road, right? Whereas if you go, 500 miles away to Colombo and drive in Sri Lanka, you won't find the same thing, all right? It's much more orderly, all right? And so the question is, why is this? And I think the reason is very simple. So these kinds of norms can't be enforced in this way, the way they're enforced in this model. Why can't they be enforced in the way they're in this model? Because if I'm sitting in a car, right, the other guy cannot impose a social sanction on me. I can barely see his face, all right? So there is no forum in which this can be done, correct? So I am essentially anonymous, and so the social sanction doesn't work, all right? Then what is the sanction that does work? The sanction that does work is that the police actually, catch you and fine you for driving dangerously, badly, breaking rules, and so on and so forth. So in Sri Lanka, for example, I just came from there last month, and I spent a lot of time on the road there. So the fines are much higher, all right? So in Delhi, if you run a red light, you have to pay 500 rupees, all right? In Sri Lanka, you would have to pay 6,000 or something like that. So this makes a big difference. The second thing is there's a lot more enforcement, police enforcement. So what's going on here? What's going on is there is external enforcement by the state, right, or the agents of the state. And in a situation where the enforcement by the agents of the state is weak, right, people get away with bad behavior. And so you learn that bad behavior is normal, right? You drive in a particular environment, you behave in a particular environment, and you learn a behavior. This is the normal behavior, right? This is the norm. Everybody else is doing it. Therefore, it's safe for me to do it. And it's okay for me to do it, right? Whereas if you are in an environment in which if you behaved like that, you would get caught and punished, right? Then that becomes the norm. You look around you and you say, well, everybody else is doing this, I better do what everybody else is doing. So in any society, how do we learn to do what we do? We don't learn to do it in the way that we learn in classrooms, right? Or that we learn mathematics. We learn to do it in a completely different way. We learn to do most of the things that we do by just looking around us and seeing what other people are doing, right? So, and most of the time, that's good enough. If you do what other people do, that's probably a safe bet that that's okay, right? And then you're in a situation, everybody's doing more or less the same thing. And then there are always going to be a few people pushing at the boundaries to see, can I do this? Can I do that? Would that be a better idea? There are always a few people experimenting. Those experimenters, what happens to those experimenters is really crucial. So if the experimenter is, look, let me try and drive at 60 kilometers per hour and this, the speed limit is 40. If you get away with that, then you'll find everybody's speed is going up, right? Because the experimenters are doing well and other people observe that and they copy it.
I guess just as a slight response, I guess what I was trying to suggest is that there's a kind of coexistence of norms and fines, if you want to call it that. Because I think what the US with, if I'm driving, that kind of someone, I'm honked at, right, by someone, and even though I'm as anonymous as here, right, there's a sense certainly of shame or something like that. So my sense is that the story that's told seems to be
So let me just respond to that. The sense of shame is precisely because I'm internalizing the norm.
Exactly.
Right? Now, you would not feel that sense of shame if somebody honked at you on the road in Bangalore, right? Because you drove in a particular way. Why? Because you cannot possibly interpret that honk as being a sign of disapproval and of thinking that society in general disapproves of this behavior and therefore I better watch out. Right? You cannot interpret it that way in this context. But in that context, that's how you will interpret it.
Yes, I totally agree.
Yeah.
And the point I guess I'm trying to say is, I'm not so sure it has something to do with smallness or moving away from those kind of societies as much as it's the sustenance of or the creation of a public in the imagination. I don't know how one would talk about that within the
No, I completely disagree. I think you're mixing up two completely different things. The norm is held in place by enforcement. If you didn't have all those police and patrol cars on US highways, you'd have chaos, right? You wouldn't have chaos today, you wouldn't have chaos tomorrow, you wouldn't have chaos next week, but in 10 years you would have chaos, right? Why? Because the norm is very strong. People will generally behave well, correct? But remember, there are always these guys at the boundaries who are experimenting with the norms, right? If the police were not there catching those people, then the norm will erode. It will change, right? More people will do that. It will become normal to drive dangerously as it is here, right? And once it's the norm, then it's no longer, you see, there's a difference between once the norm is in place, my behavior is relative to the norm because I've internalized it. But that's a completely different question from asking, why is this particular norm being held in place? And the answer there is, when you're in a big setup, a big society, which is relatively anonymous interactions, it can only be held in place by the state. It cannot be held in place by Elinor Ostrom type means. Yeah, that's a very good question. I used to think, until about a year ago, I guess, About a year and a half ago, I started to change my mind. I used to think that the lessons you learn from this are not applicable in the global context. And I used to think that the reason that this is the case was that the appropriate model for thinking about interactions between countries, for example, country governments, whether it's negotiating over an environmental treaty or whether it is, deciding whether to, bomb another country or go to war or not, that those things are better modeled in the traditional game theoretic fashion, in which you have this rational actor model and people have some payoff functions and they're looking ahead and calculating what's the best thing to do. And the reason I thought that is because, you see, if you think about this model with the social sanctions, it's really applicable to human psychology, right? These social sanctions work. They actually have some bite because of the way we people are, right? We are very sensitive to what other people around us are thinking of us, right? Why are we sensitive? Why are we like that? Well, there's an evolutionary story for that as well. Okay, I don't want to go into it here, but there's actually a very nice book by Robert Boyd and Peter Richardson called "Why Not Only in Our Genes" or something, "Why Culture Matters for Human Evolution." So anyway, Boyd and Richardson essentially make the argument that we evolved in a way that we essentially learn by looking at people around us, what's the best thing to do. And that's the most efficient way to learn. It's very inefficient to rediscover the wheel every time, right? And to reprove every theorem, to relearn every behavior yourself. It's much faster and more efficient to see, look, everybody around me is going that way, maybe it's a good idea for me to go that way, etc. Right? And because social learning imitation is efficient, an efficient way of processing new information. So you evolve psychology in which you're always sensitive to what people around you are doing and what they think of you. All right? And in that situation, social norms matter. But now you can transfer this to states. A state is not a person, right? A state is a whole complex of actors, right? So somebody goes to the negotiation table and he's been given certain instructions. You're supposed to do this, all right? We want this. These are our objectives. You have a whole bunch of resources by which you can sort of draw upon as a state to sort of plan and say, well, if we do this, they will do that, and then we will do that, and so will do this, and so on. As a single individual, you don't have those resources. You don't have that computation capability. You're not very good at looking ahead and planning, right? So I think models, for example, industrial organization, which model firms, right, and strategic behavior of firms, big firms, I think those models, it makes better sense to have the standard game theory, which is all forward-looking, right, as opposed to this, which is history-dependent, this kind of model, right? So, but to come back to why I think, maybe these norms do actually have a role to play, because I read this book by this guy, Scott Barrett, called The Strategy of Environmental Treaty Making. And in that, you realize that a lot of, if you look at even the behavior of states, there is something like concerning norms. Maybe it is better modeled as this reputational idea and repeated game idea, right, in that context, because a state doesn't want to have a reputation for breaking its treaties because that will affect it in future negotiations and so on, all right? But still, there does seem to be something about norms, even in the international arena, between states, although it's much weaker than in face-to-face interactions in small local contexts, I would say. That's kind of a very interesting book by Barrett if you're interested in those kinds of issues.
Other questions?
So I just wanted to talk about the commons in a particular context, which is some empirical work that I did in Kumaon and Garhwal some years ago with some collaborators. So let me just say a little bit about overview about forests in particular and the economics of deforestation. If you look at deforestation overall globally and also in India, it's been mostly driven by land use change, right? So it's mostly been driven by conversion of forest land to agriculture. Okay, so some hundreds of years ago, or longer ago, thousands of years ago, if you look at if you were able to be around and have a satellite image of what India looked like, you would have seen that the entire Gangetic plain would have been forested. All right. So now you go there and you see that the entire Gangetic plain is just a patchwork of fields. Right. There's nothing else essentially. So that's what we mean. That's what I mean by deforestation being mostly driven by land use change, right? And that's been true the world over. And there are some exceptions. In a few places, timber extraction has been important, and together with irreversibility. So what do I mean by irreversibility? I mean that, of course, when you extract timber from a forest, you can cut down the forest and take the wood out, and then if you didn't do anything, the trees would just grow back, right? Eventually. It might take a while, but eventually, after 100 years, the trees will grow back. But there can be irreversibilities. And the irreversibilities are because, well, you extract the timber and now you've cut down the forest. Well, now it might be a good idea. It becomes worthwhile for somebody to start cultivating it or using it for pasture or grazing their goats or something. And then once that has happened, the fact that now the forest is down, then that stimulates new activities, and those new activities prevent the forest from coming up. So that's what I mean by irreversibility. There can also be natural irreversibilities, like in the South Island of New Zealand, for example. So New Zealand, before it was settled by the British in the 19th century, was populated by the Maoris for about 1,000 years. And they mostly lived in the forest. But when the British came, they cut down the forest in the eastern plain of the South Island. And what happened was that basically the climate changed. So you cut down the forest, you didn't get this rain. The winds were very strong. So they blew off the surface soil. And then the forest cannot grow back now. All right, the soil has changed completely. So but those are mostly exceptions. Most places, the reason for deforestation has just been conversion to agriculture. And so the economics of land use change is very simple. Population growth and possibly economic growth as well. This increases the demand for food and non-food crops. The economic growth is the non-food crop part. Land then yields higher returns under cultivation than under forest. If you have more people, you have bigger demand for food, you need more crop land, you cut down the forest and you grow it. Okay. So it's really quite simple. And reforestation can occur when the demand for agricultural land falls, as happened in New England from the mid-19th century onwards. And New England is the northeastern United States, where Arjun comes from. And that's a consequence of agricultural production growing faster than demand. So basically, if you have increases in agricultural productivity due to technological progress, whatever, increases in fertilizer use and so on, then agricultural production can grow faster than demand. As I said, because of technical progress, or in the American case, which is a kind of an interesting special case, because new, more fertile lands open up later, as they did in the Midwest. So America was a sort of special case. The Europeans came, they settled on the East Coast because they came from Europe. The East Coast is not as fertile as the Midwest. And so gradually they moved west. And once they moved west and they got more fertile land there, a lot of food was grown there. And then it was no longer profitable to farm in New England. So large parts of New England that had been deforested and converted to agriculture reverted to forest. So today, if you go to New England, it's much more forested than it was 150 years ago. Okay. In India, only government basic regulation prevents further conversion of remnant plains forests. So if you look at India, most of the forest, just look at a map, right? Look at any map of India which has a forest map or vegetation map. Look at where the green parts are. You'll see they're all in hilly areas, right? Mostly. It's a little exceptions here and there. And the reason is very simple, that plains land is more productive for agriculture, so that's what gets converted first. And it's hilly land which is less suitable for agriculture that's left out. So an expansion of forest in India is not going to occur without a dramatic growth in agricultural productivity, which has to be large enough to overtake population growth substantially until food prices fall enough that marginal lands go out of cultivation, right? So this is what is called the forest transition. There's a term for it, which is basically forests coming back. This is happening in China, by the way. It's happening in China because Chinese population growth is slowing, Chinese agricultural productivity is growing. So what you have is the marginal lands are going out of cultivation because it's no longer profitable to cultivate them, right? So the prospects for this appear to be dim unless there are major public investments in agricultural R&D and extension, and other measures to reverse population growth, etc. Oh, thank you. Okay. But I didn't want to talk about deforestation today. I wanted to talk about the economics of forest degradation, which is completely different from that of deforestation. And the reason I mentioned the deforestation very quickly in 2 minutes was I just wanted to not leave you with the confusion that what I was talking about was deforestation, right? Deforestation is you remove the forest and you replace it with agriculture or something else. Degradation means that the land is not converted to another use, okay? It just makes users of the forest, firewood collectors and others, worse off than in the long run because the sustainable flow of forest products falls. So why does it happen? Okay, and this we've been through. It happens because of the commons problem. So I will skip through this. Okay, and now what I want to get to is the empirical part. So basically, better management systems provide better coordination and thus less degradation. All right. So centralized way, you have an external agency such as the State Forest Department in India. In each state, there's a State Forest Department. That's what regulates extraction. A decentralized way, you have local self-governance to coordinate extraction. So which works better? Question which I want to address in this, which will be addressed in this study. So anecdotal evidence from around the world suggests that local self-governance tends to work better, right? But there are confounding factors. The problem is, how do we know that this is really true? It seems to be, if we look casually, impressionistically, that seems to be the case. But how do you know that that's not driven by other things which are changing at the same time? Okay, so this is based on some work I did with R. Prabhakar and B.S. Mehta, this paper. And the question we asked is, which does a better job of solving the commons problem? One panchayats or the forest department? And which has a lower administrative cost? So what are one panchayats? Well, they're basically these local forest panchayats to govern forests that were set up in the UP Himalayas, that time United Provinces, in the around 1930 by the then British government. And they gradually expanded in area, and now a substantial part of the Uttarakhand forests are under these so-called one panchayats, okay, which are a sort of much less formal local form. It's official, but it's not with elections. It's just a show of hands. You elect a panchayat. All right, so it's much simpler structure than the panchayati raj kind of thing that has come around since the 1980s. So what's the method we use? We basically control for confounders using geography and history. By confounders, I mean other variables which determine degradation. So this is what the landscape looks like of Kumaon Himalayas. So the people live in villages like that. You have terraced fields, and you have some trees on these terraced fields which are privately owned, from which people get some fodder and firewood. And then usually above the village, on steeper slopes, you'll have forests, okay? And these villages tend to be, and the cultivation tends to be closer to the valley bottoms because that's where the better land is, etc. Okay, so what you can do is, here you can see there's a picture of an area which is degraded into kind of a scrubby kind of situation from being a dense forest. Okay, so I'll just skip over this history of one panchayats, okay? So what we did is we tried to do basically to try and do this comparison between forests that were governed by one panchayats and forests that were governed by the external agency, the State Forest Department, in a rigorous way. So the problem is that if you just compared these reserve forests with the one panchayat forests, you'd find that the crown cover, which is sort of a kind of the percentage of the area covered by trees, is about 11% higher in the reserve forest than the one panchayats, right? So you would say, well, if you just did that simple comparison, you'd say, well, the one panchayats, comparison of means, right? That's the comparison in our data. You would say, well, reserve forests are better preserved. But of course, you know, it's obvious that that's not going to be enough. Well, where are these one panchayat forests located? Well, they're located near the villages, right? So that's where the biggest demand is. Where are many of the reserve forests? Very far away from where there are any people at all, right? So these are not comparable situations. So what you have to do is you have to control for the other variables that determine the outcome. That's as far as the degradation is concerned, but there is the cost side of it also, right? The benefit side is this, well, are things less degraded or not, right? Which means that you get less degraded it is, the greater the sustainable flow of products you can get from it in the long run. The other side is how much does it cost to do this? How much does it cost to have this governance structure? So here's the cost comparison first. So as you can see, and the numbers are one order of magnitude different, okay? The government forests cost about 10 times as much per hectare. These numbers are per hectare, in rupees per hectare. About 10 times as much. As you can see that a lot of the money basically is going in, something is rumbling, I think my mic. Should I just take it off?
If you prefer, yeah, just take it off.
A lot of expenditure on stuff which doesn't seem to do very much in terms of the outcome, right? Plantation, forest protection, buildings, and so on. Doesn't seem to do much in terms of actually we go and measure the outcome, doesn't seem to do very much. Okay, I'll come back to the outcome. I'm coming to the outcome in a moment. So what do? We show that these one panchayats were at least as effective at conservation as the reserve forests. We compare crown cover in 1998 between the two. And for this comparison to be valid, we need to show either that the reserved and one panchayat forests being compared were identical in other respects, which is what econometricians usually try to do, or we have to show that the RFs were more naturally suited to dense forests than the one panchayat forests, in which case the bias is in favor of the reserve forests. So if we find that the one panchayat forests were doing as well or better, that's despite the bias. Okay, so that's what we do. Okay. Okay. So the most important question here, okay, so the most important question here is really, is it true that when we compare these forests, they are truly comparable, right? So supposing it was the case that the best land most suitable for forest was given to the one panchayats. Now we find that the forest cover in the one panchayats is greater than the forest cover in the density in the reserve forests. That's not a valid comparison, right? So we have to pay attention to the process by which lands were selected for inclusion into these two types, right? Otherwise, we cannot really conclude that on the same kind of land, if you converted a reserve forest to one panchayat, then the crown cover would improve or not get worse, right? Which is the policy conclusion that you want to reach, the causal conclusion you want to reach. So, at the time that these forests were reserved, back then, 1915, here's a quote from the Forest Settlement Officer, Stiff. Here we have reserved all of the tree forest of any value without going out of the way to take in every clump of trees. I have demarcated the best of the tree forest using broad natural boundaries rather than artificial lines, and I've left large fringes of forest on all sides. So what is clear here is that the reservation, the best of the forest is going into the reserve forest. Okay? Here is Clay. Stiff was doing Kumau and Clay was doing Garhwal. It was in many cases necessary to reserve all forest of any value to preserve anything at all for future generations. So again, it's the same thing. They're trying to take the best of the tree forest and put it in the reserves. So that's historical evidence looking at reading what those settlement officers wrote. Okay? Then there's internal evidence from our data which we collected. So if you look at north-facing aspect, slopes that are looking north, so this is all mountainous area, right? So slopes looking north as compared to slopes looking south. North-facing aspect raises ground cover by 20 to 40 percentage points in both oak and pine forests, which are the two kinds which are common. Reserve forests are statistically significantly more north-facing along the boundary with one panchayat forests, right? So you know that north-facing slopes favor denser forest. Reserve forests tend to be more on north-facing slopes. So what is that saying? It's saying that it's consistent with what the settlement officers wrote, that you actually find that the lands more suitable for dense forest are actually put into the reserve forest. Now let's just look at whether there could be some other explanation of this phenomenon, right? Could the reason for the reserve forest being more north-facing be that, one, villages are more south-facing? So if villages are more south-facing, since one panchayat forests tend to be near villages, they might be more south-facing for that reason. So we look in the data, villages are not more south-facing than north-facing, they're randomly situated, right? They're equally half and half. Or could it be that the settlement officers favored species of trees that tend to be more on north-facing slopes? And the answer to that, again, is no. So the two major species that you find there are various kinds of oak and pine. And it turns out that the commercially valuable species, which the settlement officers spent most of their time writing about, is the pine and not the oak. And yet it is the pine that is found more on the south-facing side and the oak that's found more on the north-facing side, right? Despite that, we find that these reserve forests tend to be more on the north-facing side. It must have been just like they wrote in the reports, because they wanted, obviously, to reserve that better forest for government use. Okay. So the conclusion that reserve forests are likely to have denser forests, naturally speaking, for natural reasons, not for management reasons, other things equal. So here's just a satellite image and a map of, and basically what we're trying to do. So we use three methods for comparing the crown cover in forests between the reserve forests and the one panchayats. And this map illustrates method one. And this is what's called a false color composite of a satellite image. And what you see, all those polygons over there, which are, those are, some of them are reserve forests and some of them are one panchayat forests. So I don't know, can you see the dark green lines? I mean, if you switch off the lights, you would be able to see it actually. But yeah, here, right? Okay, so some of these, all of this is reserve forest. They're inside these green boundaries. I don't know whether you can see them here, here, here. And the ones inside the blue are the one panchayat forests. And this yellow thing over there, this is a comparison sample along the boundaries between one panchayat and reserve forests. So this is what is called a regression discontinuity design. So the idea is that your forest is varying for natural reasons, right, gradually over the landscape. As you cross a boundary from reserve forest into one panchayat, then the variation in the crown cover should continue to be gradual, right? Because unless there's actually a difference of the management regime, unless it actually makes a difference. If it makes a difference, then you should see a discontinuous jump in the crown cover when you cross the boundary. That's the basic idea behind the regression discontinuity design. Okay. So the idea here is basically you want to compare reserve forest and one panchayat crown cover. So supposing you say Y is crown cover, and you say DYI is the difference in crown cover in one of those cross-border pairs, right? Between one side and the other side, one panchayat minus reserve. Crown cover in one panchayat minus crown cover in reserve. And that's equal to some constant, which is the difference between crown cover in the two if the difference in all the other variables was 0. Okay, dxi is the difference in all the other variables. So basically our estimate of what the difference between the two is this constant term. Okay? Because if dx was 0, so all the other variables are the same, then the difference is the constant. The expectation of the difference is the constant. All right, so here's the constant. All right, and this is ground cover in broadleaf forest with a bunch of control variables. And you can see the difference is small. It's 1.2%. So ground cover is going from 0 to 100. The difference is only 1.2, and the p-value is nowhere near close to 0. Here is the same thing, right? This is one panchayat ground cover minus reserve forest ground cover. All right, without all these other controls, except for the aspect control, right? Aspect control is very important, and I don't remove it because the boundaries are often put exactly on the ridges or on the valleys, right? So the aspect changes sharply from one side of the boundary to another. It doesn't change gradually, so it's really important to control for this aspect. But these other things are changing gradually, okay, as you cross the boundary. And notice that all of these things tend to favor reserve forests, right? Because it's the villages the one panchayat forests are close to population. So there's more demand on them, naturally speaking. And so you can see the sign of this changes. As you remove these controls, the sign, it goes from 1.2 to minus 0.7. The point is that all of these small changes are having a small impact. They're small changes because you're going a little way across the boundary, so it's not a big change, right? Right? It's a distance of 100 meters. But it still has a small impact, so you can see that here. Similarly for the pine. Okay? But anyway, the point is that if you look at all of these numbers with or without controls, none of them, they're all fairly small and not statistically significant. Okay, so that's one way of saying, well, if we try to hold everything else constant, then this, should I stop? If we try to hold everything else constant, then we don't find a difference in the ground cover. Right? Okay. Despite the fact that we know that one side was favorably selected, right? But put that aside. Now this is a more standard multiple regression. You basically chuck in, you take the whole sample, that entire area, all those polygons you saw, that was just one area. There were many in the data set. Control for everything, put in controls for all kinds of things. So this is nearby stocks in one panchayat forest. This is nearby stocks in state forests, all kinds of substitution possibilities we examine. And you find in the end that it doesn't, again, you get a similar result, that you don't find controlling for these other things. Using the standard multiple regression framework, you don't find a difference. Okay, what this table also is meant to do is to sort of see whether, basically examine this argument that, maybe these one panchayat forests are doing well because there are nearby reserve forests from which people are meeting their needs. So they're sort of running down the reserve forest and preserving the one panchayat forest. Right? So if you actually converted that reserve forest to one panchayat forest, they would no longer be able to do this, so you wouldn't see this, improvement. So what this was designed to do was to test that argument, and it turns out that that argument actually doesn't work because So this dummy here is for one panchayats, and so the question is, do one panchayat forests which are near other one panchayats, do they have ground cover which is different than reserve forests which are near one panchayat forests? And the answer here is in this case, yes. But it is the one panchayats which have the higher ground cover, controlling for presence of neighboring forests. Over here, you can see that it's the one panchayats, this is a negative coefficient, which have lower ground cover, controlling for nearby reserve forests. So actually the argument that those things are acting as substitutes doesn't seem to hold up in the data. Okay. A third way that you could do this is, again, basically the idea here, remember, is just you want to try and see that the comparison that you're making between ground cover in the two kinds of forests is because of the management and not because of something else. So you want to control for the other things. So multiple regression is one way of doing that, but multiple regression is always open to the critique that, well, you didn't measure everything. Of course, we couldn't measure soil quality, locally varying soil quality. There are lots of things you can't measure. And if those are correlated with something that matters, then you could be biasing your results. That's one criticism. Another criticism is, well, maybe you had the wrong specification. So, okay, you can try different specifications, but you still haven't exhausted everything possible. So another way of doing this is so-called propensity score matching. And here the idea is that you have reserve forests, which are called the treatment group here, and you have these one panchayat forests here, which I call the control group. And what you want to do is you want to find reserve forests which are very similar to one panchayat forests in all the other characteristics. All right? Then you match those two, okay? And then you compare the mean difference in those matches. So it's a matching method, basically. And it's a matching method. So the first method I showed you, the regression discontinuity design, that's another matching method. And it's again trying to accomplish the same thing by using the geography. Here you use all the other characteristics, okay? The problem with this kind of matching, when you're trying to match on multiple dimensions, right, is that you simply don't have enough data points, right? So if you want to match on population density, the square of population density, the distance, the time taken to walk to the nearest road, and so on, right? Many variables, all of which vary continuously. You chop them up into fine intervals, right? And then you have a vector of those, right? So to get all the possible combinations for, say, a 6-dimensional vector when there are sort of k possible categories, you get k to the power 6, it becomes a huge number, right? Much bigger than your sample. So there's no way that you can get enough observations to compare in each cell, right? To match them. So what you do is you reduce the dimensionality of the matching problem by estimating what's called this propensity score function, right? And what it is simply it's the probability that you assign to the treatment group conditional on all these x variables, okay? So you estimate that probability using some probit regression, and then you say, well, for this value of the, these x variables, right, I found this particular, the propensity score. So if the propensity score is equal, then the probability that you're assigned to the reserve forest or to the one panchayat forest is the same, right? So what you do is you match on the propensity score, and now you get a one-dimensional variable which sort of captures all the information in this multi-dimensional thing on which to match. That's the basic idea behind propensity score matching. Okay. And there are different ways of doing it. I don't want to go into the details. If you're interested, you can read more about it. But anyway, the result is, again, you get the same result. I won't go into all that. And so the conclusion out of this particular study was that reserve forests, once you do the comparison appropriately, they cost nearly 10 times as much per hectare to manage as one panchayat. That's just aggregate statistics. And they're in no better shape, other things equal. So it turns out in this example, at least in the Himalayas, you do the comparison very, very carefully. You do all the hard work. And then you find that, well, it's not that one of them is much better than the other in terms of the preservation outcome. But it is true that one of them is much less costly than the other to achieve that outcome.
So, questions about this?
Himalayas and Uttarakhand, Van Panchayats were formed long time back, and they are formal institutions. In other part of the country, such formal institutions are not visible. So how do you think the situation will be different, and what is the future there? Are Van Panchayats, do you see that in the future also, considering the problem of the commons that you mentioned right now, that in the future also they'll work in that manner? Because, I mean, the development process that is going on is going to sort of lead in a manner that they might turn against what is going on.
Yeah, yes, you're right. I mean, firstly, you can't generalize what we found in that study to somewhere else because the conditions could be different and so on. So it's a case study, right? Think of it like that. It's just that there is this general overall kind of case, sort of casual empirical evidence from many parts of the world as well as from India, which suggests that if you look at overall of these situations where you had these former colonial states basically nationalizing their forests either during the colonial period or typically during the colonial period, then maintaining the nationalization after, this is not a management system which has worked well. And there has been a lot of deforestation and forest degradation under these. But again, the problem was basically that you couldn't, in every particular case you could say, well, there might have been something else going on that explains this difference. So this is just a case study where you go to one particular area and you try to, do the comparison appropriately. And this is what we found. But of course, if you go to some other area, you may get a different result. So I can't say anything about that. You can't. Having said that, I have to say that there are some features of this which are kind of generalizable to other states. So if you looked at those cost numbers, right, you see an order of magnitude difference in the cost. Now we know why those costs are different. Those costs are different because you have a big administrative hierarchy of people who are highly paid relative to the people who are actually protecting the forests in the Van Panchayats, right? Because what do? You get the local guy who's already living there to act as the chowkidar, right? In a time when he's not busy with other things, the agricultural season and so on. So you essentially, because it's your money, right? You're very stingy about it. You don't go and hire somebody and pay him 10 times what he could have earned otherwise, right? Whereas with the government, that's the way things have been done in the past. So it's probably true that if you look at the cost part of it, that generalizes, right? Because you have the same pay structure, you have the same bureaucracy, you have the same organization, you have the same kind of spending money on buildings and stuff, which is fairly unrelated to conservation in many instances, et cetera, et cetera.
A small clarification, are Van Panchayats similar to the local communities or are they different from those? I'm sorry, I'm not aware of that fact.
Well, it's a group of 5 to 7 or 11 people who are kind of elected by, and not through a formal election, but through just a show of hands, and they manage it for 5 years. And then this Van Panchayat official comes around the next time and then they re-elect it. So it's a local council. Yeah.
So in your other paper, Biodiversity in India, you mentioned that for the local communities to have the motivation to conserve the forest, I mean, I'm digressing a little from the paper that you have mentioned there. For them to create that motivation, you need the revenues. And those revenues are actually not coming right now because for that they need the tourist revenues. In some of the places where the area is not really enriched with certain natural resources or it's not a very tourist attraction, in those particular places, the revenue might not be generated. Even that small amount of revenue that you mentioned, that might not be coming in. So given the present Tribal Rights Act and the other acts and whatever exists in India, what can we do? What do you think is done in such kind of situations?
Well, I mean, it's a very complicated situation, so it varies from place to place. So there's not going to be a one-size-fits-all solution to this thing. And also, you have to recognize that, in the end, this is a problem of governance, right? you either manage it at a higher level form, a higher level of governance like the state government, right, state forest department, or you measure it, you do it at a lower level like local. Now, doing it at the local level means that you cut out all kinds of transaction costs, okay? So you have a cost advantage of doing it at the local level. Do you have a better advantage in terms of accountability, governance, and so on? Well, it's not clear. I mean, I don't know. I don't know what the answer to that is, and the only way to find out is to try it out.
Comparing the costs of the two kinds of ways of governing forests, we seem to be ignoring the deterrent effect of, for instance, the reserve forests. If there were no reserve forests, so local communities may indeed end up plundering. But now they know that if we don't manage it properly, it could be that the state intervenes and takes it away. So even if these expensive ways of governing, we still might want to have a small percentage of the forest under the state as an example of what happens if the local community is not able to handle things on its own. So cost effectiveness is to be looked at it from this perspective.
Yeah, the point was that there is a big cost difference, but there isn't a big difference in outcomes on average. That was the point. So if there is a big cost difference, you want to have also a big outcome difference, right, in order to justify the higher cost. But here you're not getting the big outcome difference on average. By the way, one thing I didn't mention in this talk, because there's really not much time, but just to say that there was not a big difference in outcomes on average is not to say that all of the Van Panchayats are clustered around the mean. That's not the case at all. In fact, the distribution is bimodal. So you have some of them with very high ground cover and some of them with very low. So, but that's just, what I gave you was just a mean.
So just curiosity, because I have done a similar kind of study in Gujarat, but with much less of this kind of equations and all. It was more of a qualitative study. And we came to similar kind of understanding also. So just when did you did this study? One, and does this Van Panchayat still exist in these areas, Himachal Pradesh and all?
Yeah, the Van Panchayat, yeah, as I mentioned, the Van Panchayat is a very old institution. It was created in 1930 and it continues to exist. And large parts of the forests in Kumaon are, maybe half the forests in Kumaon are governed by Van Panchayats, something like that. And what was the other question? I'm sorry. Yeah, the system still continues. However, it's not as if it's an unchanging system. So it evolves, right? Oh, the study was that data is from 1998. So the data of the outcome, the measure of ground cover, the measure of costs and all, it's from 1998, 2000. And but we only look at areas that had been in that particular system for at least 15 years. So we don't look at young Van Panchayats because there isn't enough time for the difference to show.
I guess we've actually made some work for longer than